I will quickly start with what I'm going to be talking about and what are the key takeaways I would love people to get out of this conversation. I'm Arif Iqbal. I'll go over my introduction in the next slide, but this talk is mostly going to be about we are building world's South Asian fashion ecosystem. We are trying to take South Asian fashion online. I'll also explain a bit what that is. And this talk is mostly about like how we are using data in AI for solving some real problems. It's LAAM is as a marketplace, so we have on one end consumer, one end vendor, and I want to go over different examples. It's interesting. This is coming after the session of Frank, where he talked about like vector search, semantic representation. I'm going to also be going over a lot of like real world example and use cases of how we are using it, how we are utilizing it. I have been working in the tech industry for over 15 years now. I was part of the Bing search team, actually the founding team that launched Bing.com. It used to be called Live Search when I used to work there. So we launched Bing.com. So as part of the early search relevance team, we had ambitions to go out there and be better than Google. Did not go very well, to be honest. But eventually we made something, and Bing is again in the news for doing amazing like AI work. Then I went on to eBay. I was leading data science and machine learning teams there. Some of the interesting problems I worked there was like delivery time estimate prediction, missing product information prediction, as well as like missing information about product, like any missing information like text, title, and stuff. Then I joined startup Pinterest, where I was the founding member of their ads group. So there I had fun building like a lot of like ads relevance model, predicting click, and a bunch of targeting models like set expansion, lookalikes. So it was a fun time. Before starting LAAM, I spent close to 5 years at Facebook. I did machine learning and AI for search, contributed to recommendations as well as shops, Facebook and Instagram shops. These are the few high-level areas I'm going to be covering in this discussion, and obviously I'll try my best to leave time at the end for Q&A. I'll go over like what problem are we trying to solve so that when we talk about the different ways of solving those problems, we understand the problem faced in the first place. I want to talk about like some foundational product understanding models that helps us in solving the true consumer problems with AI, and some of the key lessons and takeaway from this. Problem statement. First section, this is where, what is LAAM? LAAM is a South Asian fashion marketplace that connects global buyers with sellers. If I have to describe again for a marketplace, there are two sides. One is the consumer, the customer side. The other is like the vendors. For the consumer side, where we have like hundreds of millions of people across the world, South Asians living in their own countries and expats living across the world, they really want to like go out there and discover the fashion. And one thing that I would call out is that South Asian fashion, like people coming from like Pakistan, India, Bangladesh, you would tend to see that they have their wardrobe filled with, even living anywhere in the world, they have a good chunk of their wardrobe filled there with their native clothes. So it's a problem that a lot of people have across the world. And then this part of the world is also like trying to digitize. So for example, like if I look at China, like I think 95% of the adults buy some of the fashion products online. I think in this part of the world, the number is like under 5%, but it's growing fast. So most of the vendors, most of the businesses do not have the technical tools to have that digital presence and make a good like online business. And this is where we really want to come in and help them in connecting and bridging this gap between the consumers and the vendors. I know for some of the audience, South Asian fashion might still be like a bit of a confusing term. What does it really mean? I want to like put in some examples out there of type of products that I'm talking about. So for example, like these are a few examples of kaftan, the first image which I'm showing, and there is sari, then there is like something called langa choli, there is men's kurta. And again, like as I said, there are hundreds of millions to billions of people who actually wear this clothes, very relevant to them. In terms of at LAAM, as we try to solve this problem, we started roughly 3 years ago. So this is the size of the data and what we are dealing with. In our catalog, we have more than 1,000 different businesses that we are trying to digitize or take them online. They have a combined 100,000 products. On LAAM today, on a monthly basis, they get those products that they upload on our platform, they get more than 150 million impressions. The consumers come from more than 200 countries, and we have shipped product to 100 plus countries in the world, more than 7,500 plus cities in the world in the last 12 months. And those businesses that I just talked about, those 1,000 businesses, they have direct employees of more than 15,000 people. So the technology or the product that we are building using data and AI has a huge impact on the life of a lot of people across the world, and creating like impact on the life of businesses, like creating 15K employment. Let's jump into the fun data AI stuff. As I said, like there are three high level ways I'm going to be like going over this in this talk. The first is like I want to talk about like we have a bunch of entities. I talked about customers, I talked about vendors, I talked about products, and products here like represent some image. So I want to talk about like how do we really like deeply understand them, use different type of modeling techniques to understand that part. And once we have built up those basic understanding, and I think this is again like interesting coming from the Frank previous talk about like vector search and semantic representation, some of the foundational pieces I'm going to be talking about is like essentially representing some of the entities into those in those representations, so that we can then later utilize that in our product, in the real problems, consumer problems that we want to solve. Starting out with first foundational piece, which is I'll go over like an image on the left that I'm presenting, which is one type of again product that we look at. If you look at this product, you would see very interesting embroidery being done. One of the interesting things is that there are different type of products. So for us, like one of the aspects that we want to deeply understand texture of the product. So the question comes is, and again, like I will go into like why do we need to understand the texture in solving some real problems later on. So the problem that comes is that how do we go out and understand the texture? One of the most amazing things with the AI world is that you wanna take in a lot of great work that has been done across and utilize it and solve that problem. So there has been a lot of like different image classification models. We all are aware of like how transformer models are coming in and changing. ChatGPT, like transformer plays a major role up there as well. So if you look at different models, like the transformer model that I am presenting here was essentially like was to predict different classes here. So one of the interesting things that we are doing is like we are taking the vision transformer model and essentially getting tons of label data from the vendors that are on the platform. So the 1,000 vendors that are on the platform, we ask them to start to label that data as they upload the product. So we get information, and we have also a team that hand labels that some of the data that we have missing information or correct the label that's needed. As we get that label data, we start to take that latest model and start to fine tune it based on the three classes in this case that we are trying to predict. And again, there are more classes that we are now working on and trying to predict, like embellished product. That is a lot of like handwork done through embellishment. So in this case, like we are trying to predict like whether it's embroidery or print or plain. As we train this model and fine tune this model, if you look at this particular example on the left, as we pass it through this trained model with the examples that with 100,000 products that I talked about, that fine tuning this model based on that data, we see that pretty interesting prediction coming in for embroidery, print, and plain. And again, as I said, I'm going to talk later about like how we are utilizing that information being predicted for various tasks. Something that I want to call out again is that if I look at the data size that we have today, if we had to train a model for the classification of these texture and had to train it from the scratch, this would have been like a huge challenge. And this is where, again, I think one of the key lessons I will talk about later on as well, the beauty of transfer learning, where we take on the state of the art and start to like build on top of it for the kind of work we want to do. And the other thing is that just understanding the basics of those models, like, and gives you like a decent and good idea of which one to utilize from. So for example, if we look at like, again, there is like convolutional neural networks or different like DNN techniques to solve the classification problem, but detection problem in images. But if you think about this particular model, it's pretty good at in terms of like figuring out this like region of interest where there is like some changes. And the kind of problem that we are trying to solve, like of detecting texture, again, like I'm not going into too much detail of the models, but we go over like in this particular image, what are the different regions that this model is highlighting for the prediction of embroidery? You would notice that it's really going after the regions where there is like a attention map changing or high frequency of texture changes. So as a result of that, this model is like generally going to be good. So as we trained or as we fine-tune different type of models, like this model started to give us like better classification error rate. And as a result of that, like it was pretty obvious that this is something that we need. I'm going to go over like another like foundational piece that we need to solve, which is the product classification. I showed a few examples in the start, which was around the kind of model that the kind of products that we have, which I showed some like what we call kameez shalwar and lehenga, sari. So I think for us, like one other thing is that again, our vendors are giving us a lot of data. Our internal teams are also like tagging a lot of products. So that gives us enough training data from those 100,000 products that we have on LAAM. So and as we get that product, I think one of the things is that can we start to predict the new ones that are coming in, and can we use the predicted score to feed into our model? So for example, in this particular case, we took like one of the recent like trained ResNet latest model and start to again like train, build on top of it and try to see like what kind of like prediction can we get out of it and what is the classification error that we're going to get out of it. So in this particular case, when our team trained the model, they fixed all the layers and they added on top of it. They just fine tuned the top layer and played around with it, and we were able to get a decent model out of it. And again, as I said, for us, like one of the most important thing is that we are looking at like various aspects. One is that the classification, like complexity as well as the time consumption. So some models might perform equally better, but at the same time, when we are like evaluating at runtime, where we have like few milliseconds to get the results, I think this model, like because of the skip connections that the ResNet has, was able to perform pretty decent for this example. But again, I would like to highlight that aspect that I discussed previously as well, of transfer learning, of using the model and fine tuning on top of it by just adding, by just like fine tuning the top layer and getting fairly decent results out of it. And this one is a fairly interesting one. We look at this image itself, and we have to solve like a bunch of different problems. We want to get information about this product or this particular design, but there is a lot of like background noise. There is a lot of like different objects up here. So one of the things that we ended up doing is that we get like this segmented label data for this to start to see that can we start to have can we like segment this image and get to the real area that we are interested in. So we took the UNet model, and that model was basically for like medical imagery segmentation and extracting like medical key like segment information out of it. So what we did was that we again took out our label data. We started to training on top of it. This is the result of this particular example. From this example, like you can see that once we get that region of interest up here, where we have this like particular design, we can very easily like solve for some of the problems, like finding the color of the product, because then we can just look for the color density among the whole image and figure it out. So this is again another great example of transfer learning, as well as innovative ways of using the latest and greatest and deep learning to solve what's the problem that we are trying to solve in LAAM for elevating South Asian fashion. I probably like, again, after Frank's conversation in the last session, he also explained about like in the current world, representing things in a vector is a way to find similarity or recommendation or search. So one, if I look at the kind of entities that we have in our ecosystem, I would call out that we have one, obviously, laam.pk. A lot of people go there, use it. So I'm going to call them users of our platform. Then I'm call item. So we have like, I call about like just 100,000 products that we have. Let's say I call them different items. I have vendor as well. A vendor produces like hundreds or thousands of items that they upload on LAAM. And then I can talk about like the various like first image level information and then product level information that can be represented. So one of the ideas is that as we go and solve some different problems, what would be an interesting way to have a representation or embedding or a vector, different type of entities. So this is like one of the interesting ways where we are approaching the problem is that we take a bunch of raw data that can be used to represent each user and a bunch of raw data that can be used to represent this particular product or item. So if we think about like user representation, I think I'm going to go into some of my future slides. Like in the upcoming slides, we're going to talk about like different representation and examples of that representation. But if let's say we talk about a user, we might are going to put in like his historical interactions up here, where he's located, what kind of like price range that he has purchased in the past, If we talk about item, we just discussed, like we can look at the previous classification that we have done, what kind of item it is, whether it's a sari or a langa choli that I was showing previously, what kind of like historical interactions that it had, and what kind of like color ranges it has. So we take all of this information and try to train like these two neural networks essentially, with like at a top layer we're trying to minimize the error in the embedding of things that are similar to each other. And how do we get those examples of things that are similar to each other? So if you look at, like, as I talked about, like LAAM get hundreds of millions of impressions monthly. So all those impressions, there are some positive examples that we get out of it. So for example, if you think about a user session, a user, let's say in a session, sees 50 products, but he interacts with 5 products. So we get those like 5 products that he's interacting with, and those 45 products he's not interacting with as kind of positive examples and negative examples. So what we ask the model to do is to minimize as it finds a vector similarity between and a dot product between those embeddings that are generated for user as well as that product. So the model, what it's trying to do is they're trying to minimize that error. So essentially, like we keep on giving it examples to do it on scale, and the top is a loss function. So we want to like maximize that the distance, the dot product gives us like really good score for the entities that are closer to each other and a low score for the entities that are far away from each other. So this is the error that we're trying to minimize. So at the end of the day, if we train this model, so what really happens is that if, let's say, I have 5 million users, each 5 million of those users are someone that I can represent it with a vector, a particular dimension, right? So for example, if I train this model and the user tower is, let's say, and again, like one other thing I want to call out is that those 2 embeddings that we are generating are in the same space. Because again, the model, let's say, if they are 100-dimensional top level layer of that network that we are trying to minimize the error for, they're going to be in the same space. So one of the easier ways that we can say that, oh, for a user, I want to now recommend top 20 products. I can just go out there and find the top case similar products as an example. So as a result, like we can use this methodology to generate or to semantically represent any type of entity that we have in the ecosystem based on the label data that we have and the raw features that we can use for representation. So we looked at like image representation and different entity representation. From here, like I really want to go to the consumer, the real problems that we want to go out there and solve. So the first one I want to talk about is visual search. This is I just pasted it from our website, from our product. So where you can see that I have selected this one particular image. We are showing this image. This problem has been solved by like quite a lot of other places as well. If we talk about, like, if you go to Bing, if you go to Google, if you go to Pinterest, you're going to see that you have an ability to like find similar products, visually similar products, or visually. But if I think about, like, for us, the problem is a bit different, because for us, like, visual similarity is essentially product similarity. So if I look at this product itself, we want to find the product similar to this, and what is a product in our case. So for example, first is that I'm really looking for that segmented image or the segmented product information, because other is noise, the background and everything is noise for us. So first is that we really want to figure that out. And then if you look at the details, so for example, this particular product that I'm looking at is that there's a lot of embroidery on it. So we want to match that pattern as well. So some of the previous work that I was showing you, the foundational work that we are doing now, you can see that how it's going to come in and help us in solving that problem. And it's a different problem than the way that I think Bing or Pinterest is going to approach that problem, because we are going to really go after like finding the product similarity in the context of that we want to look at it. Again, I think if we come down to this, like, we want to go one way of solving this problem, and one approach that we are taking in the early days is that we take a bunch of these features which we can use to represent the image. These can be outputs from the foundational models, their top layer that we have built. These can be some of those predictions like color prediction, texture prediction, as well as like any kind of like other information that we have around the product itself. And we can just train an encoder decoder model to try to like project that large feature vector into, like, let's say, a small 100 or 200 dimensional space and put it out there. But the feature vector that we are like projecting in a smaller space here is that, or a low dimensional space, we want to make sure that we put in the right features or right information there, which is important in the representation that we are looking for. And some of the previous model that I was showing, that the two-sided like network, that can be also very interesting approach that we can use here. just because of the fact that we also have historical interaction data. So we can train an embedding model based on what kind of interactions are happening and try to minimize the loss error there. But once, let's say this model trained, and once we have this model, the problem to find similar images becomes very easy, right? So we get the segmented image, we put it all the features out there, and then we go and find the embedding for it. And once we have the embedding, we just go out there and do a vector search of similar products. Okay, nearest neighbor in that vector search, and we get similar products. So that's the beauty of like solving a real product example using the power of tools that AI, data, and machine learning provides us. The other one I want to talk about is the personalized fashion discovery. I'm showing again a snapshot from LAAM, where a user comes in and is looking at like thousands of products that are in a and we are recommending him, or we are giving him a feed of that he wants to look at. So the problem that we want to solve is that we want to show them things that they would be interested in. So if I have to potentially put it as a problem or as like the prediction that you want to do here is that we are trying to predict the engagement with all the products. I can change that engagement very quickly, probability of a purchase given a user and an impression. Depends on like what I want to predict. But let's say if I'm predicting engagement given a user and an impression. I want to go a bit deeper into how I would want to represent those different features. We talked about some representation when we talk about like entity representation of through embeddings, but there could be like a lot of other dense features that can represent this well. So we have like, I'm talking about some interaction features historical that we have found to be very useful. And working at places like Facebook and Pinterest before, I found them to be extremely, extremely useful as we try to go after and predict and build a feed. So we have like user vendor example. Like for example, if I am a user, let's say I go to Amazon, I'm always interacting with Apple products. This information that I interact with Apple products is a very good indicator that in the future I'm going to be interacting with Apple products. So we're going to like put those historical interactions out there as a dense feature. And then we have, again, we said we are going to represent user as well as product in our embedding space. So we can find the similarity score between user and embedding and put it out there as one of the one of the great features. And then we have like different vendor features like itself. If we have a product, how good is the vendor being? For example, if there is a vendor, if you look at the example of Amazon, they have Apple vendor and then they have, let's say, Reebok. They can put in their historical performance score. Do people like interacting with one versus the other? Is their historical satisfaction rate higher for one or the other? Then we can put a bunch of like product features up here as well, some contextual feature as well, day of the week, time of the day, holiday coming or not coming. And then like bunch of these like sparse features can come in as well. So for example, each product in LAAM has a title, has a description. We can put in all those like as sparse features into the model. And we can also put in like the previous generated embeddings as just raw features as well. So with this, like we get like pretty good data, and eventually like we have historical interacting as well of as a positive examples. What are the things that people interacted with as positive examples, and what are the things that people did not interact with as negative examples? So we have the training data formulated pretty well. I want to like briefly go over. So once we have that training data, I think there was a very interesting question at the end of the previous talk, what to go for, like machine learning or deep learning. So I think this is a very interesting like hybrid approach that I want to like show up here. So once we have that training data, I can go out there and solve this problem in tons of different ways in terms of that prediction. If I think about like deep learning is a type of machine learning. So, but for let's say if I look at this tree-based model and deep neural network, I can have one model which is trying to predict the engagement using like random forest or boosted decision trees. And I can have another one which is exact same training data passed through a deep neural network, and which is again try to predict the probability of engagement. If we look at it, there's another interesting hybrid approach. I combine all of those predictions up here, or I take the last layer of those predictions coming from, so for example, my top layer, just before the classifier of my representation, I put it through a basic linear model or a logistic regression model, and try to then again predict the probability. And this could be like an interesting way to merge all of these techniques together. But I think that the notion of merging them together should not be like, oh, we want to make it look cool. It should be based on how much of a error reduction are we seeing or classification error or loss is improving as we do all of that. If let's say I do tree-based model and I do like DNN, deep neural networks, and I'm able to get to like a loss of like 10%, and by combining those models, I am able to improve it to by like 3%, 4%, and that could like mean quite a bit of engagement improvement on our website. So we are playing with all of those techniques to see like what works, but a hybrid approach is something that we are targeting, and I've seen them being targeted at some of the companies I've worked at. Cool, and this is something that we have started working on recently, but I just want to call out, and we are super excited about it as the whole world is currently with the generative AI. With generative AI, I think this is a variation of GAN, generative adversarial network, where we are using a model which is a variation on top of that, which is called style GAN. And one of the interesting things that it allows us to do is that it allows us to control some segment of the styling that we want to do through this generative. So for example, like this model has been trained on that you want to do styling just to put lipstick on a face. So what we have started to do is like for us, like as we want to provide the vendors that are on the platform LAAM, that they have an ability to get some of those creative tools to play around and generate some interesting images from the data that they have, from the product or the design that they already have. So if you look at on the left, we have these two designs. So we started to train a model on top of style GAN, which is like we are asking it that, oh, can you change the color of the shirt? So if you look at this example, you would see that, oh, we have changed the color of the shirt through this through this like generative model to a yellow color. So and we can generate like thousands of such things based on like, oh, I want to do a variation of X. So for example, the same variation can be done for the trouser itself. The same variation, some of the things that we are trying to work through is that some of the variations can be done around the texture that we talked about, that through embroidery, through like prints variation, the basic variation that can be done through the model. So this is something that we are very excited about, like work that we are doing on the. But again, I think one of the lessons, as I talked about earlier, is that a lot of great work has been done in building the base models, and that can be that allows us to bring in our own training data, some additional layers on top to tune it for our problem. Yeah, so that is another basic use of AI and data. So I talked about we have 1,000 different vendors that are on LAAM. One of the challenges that these businesses have is they are never aware of like what to produce, what to make. So one of the problems that we really want to go out and solve for them is like really start to give them prediction like through time series model. So on the right snapshot, if you look at it, you would see is that we have a bunch of products for a particular vendor, and we are giving them like, oh, what do we believe is the estimate stock that you're gonna be needed, and that gets predicted here. Historically, what we see is that they were like generally producing roughly 25 to 30% more inventory than really needed, and producing less inventory for some of the products where it was needed. With this integrated into our system, a lot of our vendors are now able to optimize, and this also like helps a lot of like wastage and environmentally like helping them as well, and business losses protection as well. So data and AI helping across the board. Cool. So these are some of the key. In the previous section, I talked about some of the key ways we have been utilizing and helping and solve some of the consumer as well as the vendor problems that we have in our ecosystem. I just want to like walk through some key lessons, some key things that I believe like anyone who's like solving some real problems that we have found to be very, very critical. One is that I think I've mentioned it quite a few times during this conversation, is that we really want to understand and utilize state of the art. So we talked about like some vision models, some like latest UNet that we are using for segmentation and training on top of that. If we think about the training data that we have and building those models, I don't think that we will get to the accuracy that we really want to get to. So one of the things that we really want to do, and this is something that back even in the days of like when I was working on Pinterest on ad relevance model, we really went out there and looked at what are the latest and greatest ones that maybe like Facebook or Google and some of the companies have put it out there. And we can either use some of the techniques or we can build on top of them if they're available. So This is something which I would highly recommend, that as you're going after and solving any real problem, figure out state of the art and start to build on top of it. The second journal learning is that training data matters a lot. Training data is extremely important. So I talked about that we are getting some label data from our vendors. So we had to put a lot of pieces. We have to put in checks in place that the quality of the data is good. I talked about some of the interesting ways we are collecting data as people are interacting on the website. So people, if they look at 100 products and they interact with 4 or 5, this gives us very meaningful, very interesting training data. So as you get the amount of training data that you have and the quality of that training data that you have is eventually going to result in how good a real world problem that you would solve. The third is we talked about various models previously. If we talk about complexity, I think there are 2 types of complexities: how much training time is going to be needed as you go and solve some of those problems, and then evaluation cost as well, inference cost as well, as you look at them. If you look at a basic example, if I have 1,000 products and I want to find similarity, if each one of them is going to take, let's say, 10 milliseconds, then I'm going to need 10,000 millisecond overall. Obviously, that's going to happen in parallel, but that's the amount of cost that I'm going to be paying in terms of inference. And same is the case with training. I showed some model that we can use for generating our feed. For those models, we have to be very careful in terms of what kind of complexity are we adding versus the gain that we are seeing. If something adds 4x more complexity and gives me a gain of 4 or 5%, I think I would be very cautious in making those calls. That is the 4 or 5% gain worth it? So this is something that we have found to be very important, to be very cautious and careful about. All the models that give small gain but increase the complexity are not always good. Yes, again, this is coming from the previous session as well, where we talked about how a lot of unstructured data and everything represented by this vector or embeddings is really changing. We have found it to be the case across the board. So something I think one of the key lessons is that as you go after the problem solving in the new world or the deep neural networks world, I think one of the ways where you really want to do out there is that you want to find a vector representation of a bunch of different entities you play with. Even whatever model technique you're using, that representation generally tends to be one of the strongest feature in any type of machine learning models. One other one that I've talked about is that as you train all of those models, there are 2 ways to evaluate them. So for example, I talked about in the visual search, we talked about that if we have some label data offline, we figure out that classification error that we want to minimize or that click-through rate we want to maximize. But if I talk about when we get that model running and we understand the cost or inference cost, there are all an experiment that we run to understand what data that we are really seeing out there. Sometimes something that is really good offline tends to look good online. So eventually, I think you want to go back because eventually we want to deliver some impact to the user of your system. So online really represents you want to go back and change your offline. So that is another key lesson that I would want anybody who's building products to keep in mind, that eventually you are targeting for online gains and you want your offline gains to be as good of a representation so that you can play around faster. The last is model training and evaluation. Everything looks great, but once something goes wrong, you really want to have an ability to figure out where to look at. So investing in debugging models is something which is very important. What that means is that, let's say if I have a model, so we talked about a feed model. Let's say if I trained that model, I would be able to see what are the top 100 features that are important. So one way to look at have an ability to debug those models is that if I look at the distribution of any feature, is that distribution changing or not? If that distribution is changing, obviously my prediction are going to change, or that feature might just have stopped working, both in offline representation and online. So your ability to be able to quickly debug such issues as you train models for solving real problems is extremely critical. So I would highly recommend to have a debugging story as you build those models. This was it.
Thank you, Arif. I know the work ahead of time, but it is always exciting to see the kind of work that you're doing, right? So,
of course, and thank you so much for inviting. It was a pleasure coming here.
Thank you.